Hello, my name is Milena Tsvetkova, and I'm an assistant professor of computational social science at the London School of Economics and Political Science. My interest in Python is closely related to my research interests in computational and experimental social science. I collaborate with computer scientists, physicists, organizational scientists, and game developers. But enough about me. Why are you here? What do you want to learn from this masterclass? Let's get to that in a while. First, let's recap what data analysis is. Data analysis is the process of inspecting, cleansing, transforming, and modeling data with the goal of discovering useful information so that you can draw informed conclusions. Ultimately, you want to take a business question or problem and provide a plausible solution or calculated forecast. In Course 1, you were introduced to Excel, Tableau, and SQL for performing data analysis. In Course 2, you're expanding your horizons with Python, which essentially can perform everything that Excel, SQL, and Tableau can, and then some more. For example, Python can do everything Excel does regarding filtering, processing, and summarizing data. In addition, Python can be used to obtain web data in different formats and model the data statistically, among many other things. Python can do the same as SQL by querying a relational database management system. However, Python can visualize the output, which SQL cannot do. Python is a programming language, and Tableau is primarily a visualization or business intelligence tool. For example, you can perform machine learning with Python, but not with Tableau. You might say, we saved the best for last. You see, when you start with a new programming language, you'll make a lot of mistakes. You'll write long-winded code. But with practice, patience, and perseverance, you'll learn to write Pythonic code. In this masterclass, I'm going to answer a few questions about Python. Number 1, what is the difference between a Python developer, programmer, and a data analyst with Python programming skills? Number 2, what advantages does the data analyst with Python programming skills have over those that don't? Number 3, how does Python compare to other tools of the trade? Number 4, why is Python a preferred tool when it comes to data visualization? What can it do that other tools potentially can't? Remember that the course per se is an ocean of knowledge built after consulting with industry experts, headhunters, data analysts, and academics. With this masterclass, I'll bring some more valuable insights that will hopefully leave you inspired and prepare you to secure that dream job. The overarching difference between the three roles is the use case of the Python programming language. Let's see how. A Python programmer develops the mathematical logic behind the software design and development. Software development is a process of conceiving, specifying, designing, documenting, and testing code. Applying various methodical approaches, a programmer can develop a fully functional software solution. Programmers conceptualize programs and the architectural framework for building websites, developing mobile apps, as well as design games to provide business solutions by developing software products. For example, programmers program machines to perform mechanical operations. A coder, on the other hand, can be anyone who can translate a set of instructions into machine-readable formats, leveraging simple scripting languages such as HTML or CSS, or complex programming languages, such as Python or R, if they have a basic knowledge of syntax, keywords, and functions. For example, the programmers leverage the code written by the coders to program a machine so that it performs mechanical operations. Essentially, programming is considered to be a superset of coding, and it's said that one can become a better coder if you can program well. Now, let's see how a data analyst uses Python differently. A data analyst typically follows a robust data analysis process that involves collecting, organizing, cleaning, and filtering data to present or visualize the insights in a format that stakeholders can understand and interpret to solve a business challenge. They write programs to analyze an existing or newly created data. The level of programming knowledge required is the main difference between a data analyst working with Python compared to a Python programmer or Python developer. Depending on the size of the business and type of business challenges, all three might end up working together on the same project with clear boundaries. If you ask someone who just learned Python as a new programming language, or someone who has been using it for a while now, they will all give you the same answer. Python is easy to understand, read, and use. Businesses prefer Python because it's a powerful open source language that helps solve complex business problems with data. Unlike Excel, you can capture data, clean the data, analyze the data, and visualize it. It's a one-stop shop. A business with a solid strategic plan can also utilize Python for descriptive analytics, for example, collating survey results and identifying trends, diagnostic analytics, for example, comparing the survey results to evaluate performance, or predictive and prescriptive analytics, for example, building a machine learning model based on the survey results and comparisons. Currently, there is a known worldwide shortage of data analysts as the demand is much bigger than the supply. So how does having Python programming as a skill give you an edge? First, Python was created as a general-purpose language. Therefore, it has simple programming syntax, readable code, and English-like commands. Second, Python has thousands of libraries that can be used to analyze data and visualization. Pandas, NumPy, Matplotlib, and Seaborn are just 4 examples. Third, Python is commonly used for developing websites and software, task automation, data analysis, data visualization, artificial intelligence, machine learning, game development, and so forth. Fourth, Python is considered to be abstract and uses natural language elements. Therefore, the whole process of coding is simpler and more automated. Fifth, Python can also be used by multiple users. You don't have to be computer scientists or programming experts to understand and write Python code. Sixth, businesses can utilize a data analyst with Python skills in various roles, making them more valuable. For example, Python developer, product manager, educator, financial advisor, data journalist, data scientist, software engineer, and many more. We can talk about this for hours, but the essence is that you cannot go wrong learning Python or refreshing your Python skills. To understand the fundamental difference between a tool like Python and products like Excel and Tableau, it's useful to take a systems thinking perspective. Excel and Tableau are largely closed, private, and operate within a clearly delineated and controlled ecosystem. Python is on the other end of the spectrum of access and control. It's an open system, specifically open source, which means it's freely available for private and commercial use. It also has a very committed community. We have some tips for engaging the Python community at the end of this section. How is Python better than Excel? In Course 1 Data Analysis for Business, you learn that Microsoft Excel now has decades experience helping businesses break down the complexity of raw data into meaningful insights. The majority of businesses today turn to Excel to analyze their data, identify, store, and sort their information, and to prepare charts, graphs, and other basic visualizations. Like Python, an important factor in Excel's adoption by consumers and businesses has been its relative simplicity and how easy it is to use. Even when compared to Python's well-known and loved simplicity, Excel's biggest advantage is its initial usability. For many programmers and data analysts, Excel was most likely their first contact with a data analytics tool, and as professional problem solvers, they are aware that knowledge of Excel is essential for working with most businesses, as this is what they understand and know. However, while Excel may have the edge in terms of ease of use and prevalence in the market, Python is still the obvious tool of choice in comparison for data analysts and data-driven businesses. It offers far more powerful automation at scale, it can handle massive and complex datasets, i.e. big data, and its versatility makes it superior to Excel at every other point of comparison. Let me share an example. In October 2020, Public Health England was rocked by a scandal because they failed to report nearly 16,000 positive COVID cases. Because of this, contact tracers failed to track down these individuals' potentially infectious contacts, leading to a likely preventable increase in the spread of the disease, numbering tens of thousands. What was the problem? It turns out Public Health England used an Excel spreadsheet to store the data, but Excel files have a limit of 1 million rows only. As a matter of fact, they even used an older Excel format that discarded any data after storing 65,000 rows. Using Excel to store and analyze data doesn't leave much room for a business's datasets to scale safely, and there will be errors as a result. Datasets tend to grow, and this presents a problem for an analyst who has to ensure analyses are correct at all times. This frustration is a reason why I've moved from the spreadsheet to programming, specifically Python with the Pandas library for data analysis. Perhaps surprisingly, even for something as simple as storing and processing data, Python sneaks ahead of tools like Excel. But how is Python better than Tableau and SQL? Query languages like SQL that make data accessible are just the beginning. Powerful analytics and visualization tools such as Tableau are essential to harness data impact business decisions. As we saw in Course 1, the visualization capabilities of Tableau ensure that you can communicate insights in a way that is clear and easy to understand. Tableau's powerful visualization capabilities and the time-saving ease at which they can be created are two of the biggest advantages it has over Python. So where does Python have the upper hand? Like Excel, Tableau operates on powerful proprietary software that is fundamentally closed. In other words, it's a no-code environment. With Python, on the other hand, having access to the source code gives businesses greater control over their product, most notably around how data is reviewed and versioned over time. The competition between the two tools is close, at least in this limited case. Python can produce the same visualizations and similar dashboards as Tableau, which makes the decision to go with one or the other challenging. The choice will, of course, depend on the specifics a business is trying to solve and its sense of strategic scaling. But usually, Python is the preferred tool when it comes to visualizing complex data. Data analysts tend to work with big data and relational database management systems. Therefore, SQL and Python are a great combination. SQL is a query language, and you cannot visualize data with SQL. Therefore, combining Python and SQL gives you the option of querying relational database management systems, analyzing data with Pandas, and visualizing with Matplotlib and Seaborn, for example. As I mentioned earlier, Python is like a one-stop shop. You can collect data, wrangle and clean the data, perform data analysis, and follow-up visualization. Data outputs can be saved in various file formats and exported to your computer for future reference or sharing with stakeholders. Data visualization programs like Tableau are very expensive, and not all businesses can afford the yearly licenses. Also, Python is preferred to Tableau for machine learning and more advanced or complex data analysis. Some data analysts and scientists prefer R to Python for visualization when publishing in academic journals or journalistic media. However, if you have an in-depth knowledge of Seaborn and Matplotlib, you can also create fantastic visualizations for publications. Python has various visualization libraries, of which Matplotlib and Seaborn are well known. Let's look at these two powerful libraries. Matplotlib is a comprehensive library for creating static visualizations. You can create quality plots, customize them, export to many file formats, and embed in a graphical user interface with Matplotlib. Matplotlib is well integrated with NumPy and Pandas. Therefore, it can work with arrays and data frames. You can create bar, pie, line, and scatter plots with Matplotlib. Seaborn is a library that is built on top of Matplotlib and closely integrated with Pandas. However, you have to understand NumPy, Matplotlib, and Pandas before you can learn or use Seaborn. Seaborn also provides a variety of visualization patterns and specializes in statistical visualization. For example, it is particularly useful for visualizing the distribution of data and time series. You might ask, which one is better? It depends on your business question, audience, and scalability. With Matplotlib, it's easier to customize figures, while Seaborn uses less syntax and has stunning default themes. For example, if you work with standard visualizations, Seaborn will be the easier choice, but if you need custom plot panels or annotations, you will not be able to do those without Matplotlib.